Welcome students. Last time we had completed till question number 5 of exercise 2.5. Today we will complete this exercise and hence this chapter also. So before going to next question, let us introduce a new identity. Till now we have done identity that were dealing with squares. So we did first 4 identities, and in fact 5 identities: a plus b whole square, a minus b whole square, a square minus b square, x plus a, x plus b, and the last one was a plus b plus c whole square. So all these identities were dealing with whole squares or squares. Now we are going to step into cube arena. So the next identities that we will be doing will all be dealing with cubes. So like a plus b whole square, we have now identity dealing with a plus b whole cube. So this is identity a plus b whole cube. Remember, there should be whole cube for this identity to be applied. In case there is no whole cube, then we will see that individual cubes, how we have to deal with them. So a plus b whole cube gives a cube plus b cube. That is pretty much obvious, that because we have cubes here, so we will have individual cubes here. So this is pretty much obvious, as well as this is intuitive also. So you must have thought it before even me telling this. So a cube plus b cube, these are the obvious terms. But now 3ab, even this you can assume, or you can derive from a plus b whole square entity. There it was square, so we had 2 here, 2ab. Here it is a cube, so we will have 3ab. Okay, but that's not all. Why? Because in addition to these terms, we will be applying a plus b here also. So you can learn this, or you can open this to learn this identity. A cube plus b cube plus 3ab into a is 3a square b, that is a into a square, b will remain as such. Now plus 3ab into b is 3ab square. Okay, so this 3ab gets distributed over a and b, that becomes 3a square b and 3ab square. Now look at the terms here and let us compare them with the identity we had done earlier, that is a plus b whole square. So it was a square plus b square plus 2ab. Yes, some students might think that they had done a square plus 2ab plus b square. That's okay, because addition is commutative. You can write 2ab in the middle as well as in the outer part also. So there is no difference. Now see here, the power of this term is 2. The power of this term is also 2. And what about the power of this term? We have variable a and we have variable b, and a and b both power gives 1 1. So 1 plus 1 is 2. So each term of this identity has a power of 2. Why 2? Because here it was 2. Now let us observe this term. The identity is this identity, terms of this identity. So we have a cube here. We have a cube here. This is a square and b1, 2 plus 1 is again 3. This is a1 and b2, again 2 plus 1 is 3. So you can see here that each term has a power of 3 here in this identity, and that is pretty much obvious. Why? Because there is 3 here, cube here. Okay, so this thing applies to all the identities. Even in the earlier identity in which we dealt with a plus b plus c whole square, we had 6 terms and all had power of 2. Okay, so this thing is quite helpful for you preventing the common mistakes. The most common mistake that the students commit while applying this identity is they will write a cube plus b cube plus 3ab only. They will not write a plus b here. Okay, so this is wrong. Why? Because if you write 3ab only, then a and b will have 1 power each. So 1 plus 1 is 2. That cannot happen because we have 3 here. So there has to be a power of 3 in each and every term. Okay, so moving forward, this was the discussion about the identity. Now let's move forward. In case we have a minus b whole cube, okay, so I'm writing with another pen, let's say another color, let me choose dark red or brown. Okay, so if a minus b whole cube is there, then a cube will remain positive. And what is positive? A. Why a positive? Because a was positive here also. Okay, then here will be minus b cube. Why minus? Because b was negative here also. A minus b, that means b is negative. So b is negative here. Again, here will be minus. Again, here it will be minus. In case you open this identity, that means you go from here to here, this will stay minus. This will remain minus also. But minus minus will get plus here. That means the term having the negative term having square will become positive. Okay, so that is why it is always recommended that you do this identity. That means identity is same, but you learn up to here. Why? Because in case you are learning up to here, you will apply negative in each and every term wherever there is positive except a cube. So you will be applying negative here, you will be applying negative here, you will be applying minus sign here also. Okay, but in case if you are learning this, then be very careful that you have to apply negative to only those parts where the power of b is odd, that is 3 or 1, but not where b is even power, that is square. Okay, so my recommendation, learn this one. Okay, not this one. This you can derive from here also. So don't learn this one, learn this one. So these are the two identities. Okay, I have done two identities in one identity. So you can separate the identities. A plus b whole cube is a cube plus b cube plus 3ab, a plus b, and a minus b whole cube is a cube minus b cube minus 3ab, a minus b. Okay, and this identity is quite useful in other questions also that we will see later. So let us start with the parts also now. So first part, no, I'm not going to do that. Second part is quite easy also. I'm doing third and fourth part. Okay, so let me start with the third part, and of course first two parts will be your homework. So it is 3 by 2x plus 1 whole cube. So according to the rituals or conventions, we have to firstly mention that what is a, what is b. So I'm doing this for only this part, but you have to do it for each and every part. Okay, so here means here in this part I'm writing here. So here a is equal to 3 by 2 times x, and while referring to a, you should have written this identity either under this or over this. Okay, so you have to write identity, it carries marks, it carries weightage, so be very careful. So a is this and b is 1. Okay, Now let's start with the identity. So we know that a plus b whole cube is this much, and y plus, because in question also we have a plus sign here. So a plus b whole cube is a cube plus b cube plus 3 b a plus b, that is 3 by 2x plus 1. And now cubing 3 into 3 into 3 will yield 27. Okay, don't do 3 3 is 9. This is one very common mistake. You have to multiply 3 times. Okay, so 3 3 is 9 3 are 27. Similarly, not 2 3 are 6, it will be 2 into 2 into 2, that will be 8. And x cube will remain x cube. 1 cube is 1 cube, 1. 3 3s are 9 upon 2 times x, 3 by 2x plus 1. Okay, here we have 27, 8x cube plus 1 plus 9 3s are 27, 27, x into x is x square, and 2 2s are 4. So I have multiplied 9x by 2 by 3x by 2. Now it's the turn to multiply 9x by 2 with 1. So anything multiplied by 1 is the same thing. So this is our answer. All the times are alike, not like, so unlike. So therefore we cannot add or subtract. So this one is your answer. Now moving to the next part, fourth part. We have x minus 2 by 3y cube. So now this you can compare from here, that you have a and b and there is a sign of minus in between. That means we have to apply a minus b whole cube. Okay, so just writing what we have here, a is x and b is, okay, now be careful, I'm not going to write b is equal to minus 2 by 3y. I'm just going to write 2 by 3y. Why? Because I'm going to apply a minus b whole cube. So the minus sign here is equal to minus sign here. B has to do nothing with this minus sign. In case you are applying a minus b whole cube, then b has to do nothing with this minus sign. Why? Because it is already included in this identity. You remember what we did in identity a plus b plus c whole square. We had only a plus b c whole square. We didn't do that a plus b minus c whole square, neither a minus b plus c whole square, neither a minus b minus c whole square. That was because there was no separate identity for that. Okay, we didn't do any separate identity for that. But here we have two separate identities, one for the plus sign, one for the minus sign. So you will write a is equal to x and b is equal to 2 by 3y, not minus 2 by 3y. So applying the same identity over here also, so it will become a cube, a is this, so a cube plus, sorry, not plus, minus 2 by 3 y cube, that is b cube, minus 3 a b and at last a minus b. So x cube is x cube, minus 2 cube is 8, 3 cube is 27, and y cube is y cube minus. Now this is 3 into x into 2 by 3y. So since this whole is one term, in fact not from here to here, in here to here it is one term, but leaving this bracket for now, what I'm doing is I'm cutting this 3 with this 3, and you can cancel this 3 by this 3. Why? Because it was a same term matter. Okay, but you cannot cancel this 3 with this 3 because these are two different terms. So be very careful in these small things. 2 into x into y. So we are left with 2 into x into y. Here we have x minus 2 by 3 times y. Okay, now last step, that is the concluding step. 2xy into x, that will give 2x square y. And minus 2x into minus 2 by 3y is minus minus plus. 2 2s are 4. X is x. Y into y is y square. And this is 3 here. So that's all about question number 6, fourth part. Let's move on to the next question now. Now seventh question. Seventh question is just application of the sixth question. The identity we did there also. We have to apply here also. So there is nothing new. We have done this question, this type of question in class 8th also. So I'm just demonstrating one part, and I think you will be able to do other two parts. So let me do the last part, that is the third part. So seventh question, third part. Here we go, 998 cube. Now here it is cube. What my purpose is to make the calculation of this cube easier. So either I can multiply 998 3 times, that means 998 into 998 into 998, but that will be quite clumsy. So what I'm going to do is I'm going to use identity. It's written over here also, so I have no other option. So what will I do? I will rewrite 998 as 1000 minus 2. Okay, you will always try that you write something as 100 plus 2 or 100 minus 1 or 1000 plus 2 or 1000 minus 2 and so on. So this term should be multiple of 10. So a minus b whole cube is a cube minus b cube. Use brackets. Okay. Don't be miser while using brackets. You have plenty of brackets, so use brackets, especially in case where there are negative signs present. So be very careful with minus sign. So a cube minus b cube minus 3a b a minus b. So 1000 into 1000 into 1000 is 1, 2 and 3 times 3 zeros. Okay, 2 into 2 into 2 is 8, 3 into 2 is 6, 6 into 1000 is 6000, and this is 1000 minus 2. Although I can write 998 here, but still I'm not going to write that. So I have 1000 times 1000 times 1000. So how much is this? This is 1 billion. Okay, so 9 zeros 1 billion or 100 crores, whatever you might like to say, 1 billion or 100 crores. Minus 8 minus 6 000 again. How much is this? This is your homework. Okay, so how much is this? Here are 6 zeros. In international system it is million, but in our system how much is this? That is up to, that is your homework. Okay, so minus into minus again plus, and 6 2s are 12, 1 2 3 zeros here. Now at last what you have to do is you have to calculate all these. So what I'm going to do is I'm first of all adding this and this term. Why? Because they are both positive terms. So how much will it yield? 3 zeros will remain as such, then comes 2, then comes 1, and the other 3 zeros and 1 again. You can vertically place this here also, in rough work. Now this is minus, minus is plus, so this is 60 lakh, so 60 lakh 8, okay, 60 lakh 8 it should be. Now subtract this term from this term. Let me do it over here. I'm doing it with a different color so that it might not get mixed with the original question. The color is not changed. So it is 1 triple 0, 1 2 triple 0. Under this we have to write 8, then 5 zeros, and then 6. So 10 minus 8 is 2. We had carried 1 from here, so 9, 9, 1, 1, 0, 4 and 9 and 0. Okay, so the answer should be 940 11992. If I have to put commas, then it should be like this: 94,11,992. So you need not to put commas, but it is easier to pronounce the number this way. So this is how you will attempt 7th question. The other 2 parts are your homework, so I'm not going to do them. So let's move forward. Now the next question is a very common question in this chapter, and that is factorize. So factorize, again, I told you earlier also that in this chapter you are going to have a question saying factorize, and you will have plenty of method to factorize, but you have to choose the correct one. So how will you identify these questions? First of all, let us see what is our first observation here. So this is the preliminary examination, that means the first examination. In all these parts, what we are observing, that there are 4 terms: 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. So every one of them has 4 terms. Okay. Next, I can see a cube in the first 2 terms, and the next 2 terms also have a power of 3. 2 on A, 1 on B, 2 plus 1 is 3. Similarly, 1 on A, 2 on B, then 1 plus 2 is again 3, that is 3. So in all the cases, I have a power of 3 except this 5th one. In 5th one, I have power of 3 on the first term only, but the other 3 terms we have power of 1 or 2. So this is something different, but all other are same. There is also a term containing only 1 as power here and 1 as a power here, 0 as a power here and 1 as a power here, 2 as a power here. So here also we have we do not have power of 3 in each term. Okay, now let us examine these 2 parts. Cannot I write 27 as 3 cube? I can write, yes. Similarly, cannot I write 1 upon 216 as 1 upon 6 whole cube? Because 6 6 are 36, 6 are 216, 6 cube is 216. So 1 cube is 1, 216 is 6 cube. That means I can write 1 upon 216 as 1 upon 6 whole cube. Okay. So here we have cube cube, not a cube, not a cube. Okay, here we have a cube, you can reduce it to cube also, then not a cube, not a cube. So we have cube in some of the parts. Okay, so the identity containing cubes is a minus b whole cube, a plus b whole cube. You will study in the next question a cube minus b cube, then a cube plus b cube. There are two terms, here there are four terms, so of course they cannot be applied. Then you will be studying about a cube plus b cube plus c cube minus 3abc, okay, in the coming questions. That means wherever you will study cubes, you will not find four terms. So the only possible case is that the application of a minus b whole cube or a plus b whole cube will be here. So how will you apply those identities? Let us see. So what should I do? Let me start with the first part. It is the only part where there are all positive terms. Okay. So we have 8a cube plus b cube plus 12a square b plus 6ab square. Okay, I can rewrite as a cube b cube. So we have a cube plus b cube. Now this is something that I didn't recommend you. So what I'm going to do is I'm writing here 3ab, okay, a plus b. From where do I get a and b? Here it was 2a, here it's b, so it should be 2a plus b. Okay, so if I open it, I'm not going to open it, because if I am going to open it, okay, I can do one step. Yes, I can open it till one step. So here it will be 3 into 2, that is 6ab, into 2a, that is 12a square b, and 3 2s are 6, 6ab, 6ab into b is 6ab square. So you can see the last two terms are same. The first two terms can be written as this, and this identity was a plus b whole cube, so it should be a, that means 2a plus b whole cube. According to the identity we are just done. So this is the same, just we have done the reverse process, that is called factorize. In the sixth question we had expanded, so here we have contract. Okay, we have packed the terms. Now let's move on to the last part, because if last part is done, then you can do the rest parts also. Fifth part, 27p cube minus 1 upon 216 minus 9 upon 2p square plus p. Again I can write 27 as 3p cube. I can write 1 upon 6 cube, then here it should be 3a b a minus b. It is a cube minus b cube minus 3ab a minus b. What should I do? We need to apply this. Let us see whether 9 by 2 p square comes or not. So if I solve this, you will get 3 to the 6. Okay, so I'm just going to do it, then I will erase it. You need not to do this. I'm just demonstrating you that it will change to 9 by 2 p square plus 1 by 4 p. Okay, this should be 1 by 4p. Okay, so 3 2s are 6, so 3p upon 2, 3 3 are 9, p into p is p square, so 9p square upon 2, correct. Then again 3p upon 12, 3p into 1 is 3p and 2 6 are 12. So what is 3p upon 12? That is p by 4. P by 4. Okay, so that means our judgment is correct. You have to apply this identity. Okay, so let's pack this. This is a minus b whole cube. So we have factorized 4 terms to 1 term. Okay, now let's move on to the next question. Question number 9 is to verify this these two parts, and you have to learn these two parts also because these two are two very distinct identities. So you need to learn these results. Why? Because you will be applying these identity in many parts further, so you have to learn them. So the first identity I would say is x cube plus y cube, that will be x plus y, x square minus xy plus y square, and the second one is x cube minus y cube is equal to x minus y, x square plus xy plus y square. I am combining them so that you can easily grasp them. So I'm writing in capital letters, block letters, x cube minus or plus y cube. First of all, plus y cube. This is x plus y. You can see the same sign over here. Okay, and then you have x square plus y square minus xy. This is interesting. Why? Because here it is minus. In case it is x cube minus y cube, then it should be x minus y here. This stays plus positive. Why? Because you can see that there is some noble hand over x head as well as y's head. Okay, God's hand. That means the power of even power square. So when we have even power, then even the minus sign fades. Okay, it vanishes. So minus square is positive. You know that. You know this. So that is why we will not have minus square. Okay, minus square of x or y in this identity. In fact, except in x square minus y square, you didn't have any negative sign in any identity over with squares. So squares are always positive. Okay, except in x square minus y square. So this is positive, will stay positive, but this will become positive. So what we are observing here is when it is a positive sign here, then all good except xy. Xy will be of opposite sign, that will be minus. If it is minus, then it will be minus according to this. These are squares, that is why they will remain positive, but this xy again goes against the LHS, it will become positive. Why? Because it was negative here, so it will become positive. Okay, in simple language कि xy की LHS के साथ बनती नहीं है, वो हमेशा उल्टी दिशा में जाएगा. अगर वो नेगेटिव है तो ये पॉजिटिव हो जाएगा, अगर वो पॉजिटिव है तो वो नेगेटिव हो जाएगा. सो इस चीज को ध्यान में रखते हुए लेट्स मूव फॉरवर्ड. वी हैव टू वेरीफाई दिस, एंड वेरिफिकेशन we need LHS is equal to RHS. So what I'm going to do is I'm going to do only one part. Second part, the first part will be done exactly same as the second part. Okay, so first part will be done in exactly the same manner as I will be doing the second part. That will be your homework. X cube minus y cube This is your LHS. So LHS is already so simplified that I need not to simplify it further. It is already so simplified. So I'm not going to touch LHS. So leave it here. RHS. RHS is x minus y, x square plus xy plus y square. So we know that x will first get multiplied with this whole bracket. This is how multiplication in brackets work. So x square plus xy plus y square, then minus y parenthesis start x square plus xy plus y square. Simple multiplication. I'm not doing anything extra. X into x is x cube, x plus xy is x square y, x into x into y square is xy square. Then be very careful, it's minus y, the signs are going to be changed now. Minus yx square minus xy square minus plus minus y cube. So you can see here x square y, again x square y, but here it is positive sign, here it is negative, they should cancel. Now x y square, again x y square, but here it is positive and here it is negative, so they should cancel, leaving behind only x cube and minus y cube, which was equal to LHS, and hence proved. Okay, so hence verified that LHS is equal to RHS. Again observe that here power is 1, the power is 2. Okay, so 1 into 2 is, sorry, 1 plus 2 is 3, because when they will get multiplied, so here it becomes 3. Similarly 1 1 1, that is 3. 1 2 3. Okay, 1 2 3, 1 1 1 3, 1 2 3. So all the terms have a power of 3. Why? Because the power is 3 here also. Okay, so this is a common observation that you should observe in all the identities. This will help you in some way or other and prevent you from doing any mistake, committing any mistake. The first part is your homework. We are going to move on to the next part, next question. Now the next question is the application of these identities that we have done in the previous question. So I'm not going to erase them, we are going to use them in this question also. So I'm pretty much lazy over here. Okay, so what we can observe here, first of all, the question is factorize. Again factorize, again you have to identify what identity you should use. Again you have to do preliminary examination, again observation. So let's start observing the question. What I can observe at the first sight is there are two terms, here also as well as here also. So two terms having cube over them, so it should be this identity. Okay, x cube plus y cube. So whenever you see two terms having individual cubes over them, you will be applying this. Whenever you see cubes and 4 terms, you will be applying a plus b whole cube. So whole cube and individual cubes, they are the two separate identities, like whole square and the different squares, a square minus b square. So applying same identity over here also, what we are going to do is, I'm going to do the second part. As usual, you will be doing first part by yourself. So 64 m cube minus 343 n cube. First thing first, m cube is cube of m, okay, but 64 is not included in that cube. You have to find the cube root of 64 so that you can apply bracket and put cube over there. So 64 is cube of 4. So I can write 64 as 4 and m cube as n. So 4m power whole cube minus 343 is 7n cube on the similar lines. Okay, so one very common mistake is that the students consider m cube as a cube. So what they do is they consider uh, x as 64m, but it should be 4m. Okay, 64 is beyond the scope of this cube. This is the personal property of m only, but 64 can be written as a perfect cube of 4. So 4m, now this is the joint property of 4 as well as m. Okay, similarly this is joint property of 7 as well as n. Now so now the way is clear to apply this identity. A cube minus b cube, that is a minus b, see here, a minus b, or x minus y. Okay, x square plus y square minus, or plus, it should be plus. Why? Because here it is minus, so it should be plus here. So 4m into 7n. I am applying curly brackets, you can apply square brackets also. So 4m minus 7n, you are not going to do anything with this. Then we have 4 4s are 16, m square, we have 7 7s are 49, n square, and we have 7 4s are 28, mn. What I can do is I can open the brackets, but this is a very silly mistake. Okay, I know how to open brackets, but if I open the brackets, then I will have three or two different terms, because after solving this you are going to get again this again. So 64m cube minus 343 n cube, we had to factorize them. Factorize means something multiply by something. So we have already factorized this question. Okay, it may look like this is quite longer lengthy term, but it is so. So we have no other option. X cube minus y cube is x minus y, x square plus y square plus xy. So it's it, that's it. First part is homework as usual, you will be doing is it yourself. Another question dealing with factorization. Again we have to factorize 27 x cube plus y cube plus z cube minus 9xyz. So you can see 4 terms here, but and 4 cubes are also there. So sorry, cubes are also there. I told you that whenever you see cube 4 terms, you have to apply that a plus b whole cube or a minus b whole cube. But the next observation is that I can observe 3 different variables here, 3 different variables. And what we did in earlier identity number 5, that we had dealt with only 2 variables, but here are 3. That means that identity a plus b whole cube or a minus b whole cube is not going to be applied here over here. So we have to think something different, and this is the time to do next identity, that is a cube plus b cube plus c cube minus 3abc equals a plus b plus c. Okay, a square plus b square plus c square minus a b minus b c minus c a. So this is the new identity that we are going to apply here. But before moving further, let us compare this identity with what we have done just now. I'm going to compare it with a cube minus or plus b cube. Again we have individual cubes over here. A is personal property, B is personal property, C is personal property. We had already done personal properties in 2 different variables, personal cubes. Here we wrote a plus b, a square plus b square minus ab. So a cube plus b cube plus c cube minus 3abc is there. Forget about it for the time being. So a cube plus b cube was a plus b. Similarly, a cube plus b cube plus c cube should be a plus b plus c. Okay. So first comparison clear. Next we had squares of a square and b square, both the variables. Now we will have again squares of a square, b square and c square. All positive. Why? Because squares are always positive. Even powers are positive. Next we had minus mixed term here. Again we have minus mixed terms here. Here you should be thinking that minus abc should be here, but again this term power 3, this term has power 3, this term has power 3, this term 1 1 1, that is 3. This term, if I multiply a into a square, will yield 3, b into a square will yield 1 plus 2 3 3. Everything will be 3 except a into a plus b plus 3, a into abc. Why? Because a into abc will yield power 4. So this cannot happen. So that is why we take only two terms over here, ab. Okay. So this is the identity that you need to learn. Learning is easier when you correlate your earlier learning. So that is why I always correlate what you have learned earlier with the new things. Okay. First of all, I have to write this in this form. 27 is not included in this cube, so I should write it as 3x cube. So 3 cube will yield 27. Y cube minus z cube minus 3 a b c. See, I am not going to write minus z over here. Okay. Next no need to write minus z. Reason being, there was no minus here also. Okay, so no z, no minus z, so it was my mistake. Okay, now next it should be like a b c. So what is a? 3x is a plus y plus z, new bracket, 3x square, put brackets, plus y square plus z square plus minus 3xy minus yz minus 3xz. So this will be giving us 3x plus y plus z 9x square plus y square plus z square minus 3xy minus yz minus 3xz. Okay, so that's all. This is your answer. Why? Because if I'm going to open this, you will be getting this again. So don't open. You have something multiplied by something. That means factorized form. Okay. Okay, now let's move on to the next question. Verify that x cube plus y cube plus z cube minus 3xyz is equal to half of x plus y plus z x minus y whole square plus y minus z whole square plus z minus x whole square. I'm just going to start. LHS is very easier, so is already simplified. I'm not going to simplify this much further, so no need of touching LHS. I'm just writing it, x cube plus y cube plus 3xyz. Even no need to write also, so I'm writing RHS only. RHS is half x plus y plus z for z. Here you can see we have a minus b whole square. So what we can do, we can simplify it to a square plus b square minus 2ab. Similarly, a square plus b square minus 2ab. Why? Because again you had a minus b whole square. Again the third term is also a minus b whole square. So we can write a square plus b square minus 2ab. Okay, so half a b c, I mean x plus y plus z, x square plus y square. You can see there are two x squares, so x square plus x square is 2x square, y plus y square plus y square is 2y square, z square plus z square is 2z square. Okay, minus 2xy minus 2yz and minus 2zx. Next, I can easily, ये तो ऐसे ही आता जाएगा. Okay, so this is not going to be not going to change. I can easily take out 2 from this term. Why? Because 2 is coming in all the 6 terms, so 2 is here common. So we are left with x square plus y square plus z square minus xy minus yz minus zx. This 2 and this 2, they are going to cancel each other, so we are left with only x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. You can easily observe that this is nothing but what we had done earlier. This is RHS of this identity. अभी किया था सेम वही आ गया और यही हमारा LHS था. So LHS is all equal to RHS. Okay, let's move on to the next question. Okay, this is the last question that we are going to do. The rest 2 questions will be your homework because they are easy, but they are important also. So last question, question number 13, very important. This year also it had come in the session ending exam. So if x plus y plus z is equal to 0, show that x cube plus y cube plus z cube is equal to 3xyz. So we can do this in 2 ways, one for 1 mark and the other one for 3 marks. I'm going to demonstrate both the ways. First, for if the question comes for 1 mark. So this is the condition that x plus y plus z is equal to 0, and this is what we have to prove. If you see this question, this part, that is what we have to prove, you can easily observe that we have 3 variables having cube on them, and for this we have already done this identity, x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. Here x plus y plus z is equal to 0. So if I put 0 over here, then 0 being the most powerful number in mathematics will turn everything into 0. So whatever you write here, if you are going to multiply with 0, you will be getting 0. So x cube plus y cube plus z cube minus 3xyz is 0. And if I transpose this term minus 3xyz over RHS, so you will be getting your answer, it is 3xyz. So this you can do for only 1 mark, but if the question carries 3 marks or so, you need to elaborate further. Then how will you do this? Let us see. If the question carries 3 marks, although in mathematics and sciences the length doesn't matter, but don't take chances. For some teachers it may be quite short for 3 marks, so that is why you should learn this method also, although I have no problem with the first one also. So x plus y plus z is equal to 0. So what I am going to do is I am transposing z over here. Okay, so x plus y is equal to minus z. You can transpose y also, you can transpose x also. There is no particular attachment with x, sorry, z. So you can take anyone to the RHS. Now what we can observe here, that we have cubes. Okay, we have to deal with cubes, so cubing both sides. Cubing both sides, what you will get? A cube plus b cube. Why? Because there are two terms. Okay, so two terms means a cube plus b cube plus 3ab a plus b, and minus z cube will yield minus z cube, because odd power is there, so minus will stay minus and z cube will become z cube. Now see the magic of this identity. I told you earlier also that there is a benefit of learning x cube plus y cube plus 3xy x plus y instead of learning x cube plus y cube plus 3x square y plus xy square. What is the benefit? Again, I need 3xyz, but here I have 3xy, there is no z, so I have to convert this x plus y into z, and there should be a relation between x and y and z, and there is a relation x plus y is equal to minus z. So what I am going to do, I am going to write minus z here, all else remains same. So this becomes x cube plus y cube minus 3xyz equals to minus z cube. So a little arrangement, transposing these two RHS and these two LHS will yield us our answer. So this is our answer. For 3 marks or 2 marks you can do this one also. You can do any one. If I am going to check your copy, I am not going to give priority to the length. So that's all for today. Question number 14 and 15, although they are very important, 16 also, but they are direct application of what we have done earlier. Question number 14 is just application of this identity. No, you will not say this as identity, because as per definition of identity is true for any values. So what I can say is that for this condition you can apply this this result. So question number 14 is based on this result only. Do it very carefully. It is very easy, very easy. Question number 14 and 15 and 16, they are just middle term splitting or factorization that you have done earlier. So all the identities, all the methods, all the techniques you have learned. Now the chapter is complete and we will be having a test very shortly. So be prepared. That's all for today.